Hello, Professor. Today I'm gonna explain the examination for. Sorry if I my recording video doesn't have camera because my device doesn't have camera. So I might not able to include myself in the video, but I hope you can recognize my voice. So first we have this transfer function. So first we have to consider this inner loop, and we use the closed loop method to find the GS transfer function of this loop. And then when we get this loop, the closed loop, we need to multiply all the loop together here, or the function here, by using the open loop. And after multiply, we got our final function, which is GS equal to 5k over this one. And then today I will use lead compensator design to design the function or the controller. So first up, we have to find the value of k. As we know that they ask us to find the design the controller that has the steady state error maximum is 0.1. So assume it to be a unit step function. So we apply this formula, and we can find value of k equal to 18. And then when we get the function 18, we multiply the k into the GS, and we got 90 over s skip and this function. And then we use this one to plot in the MATLAB code, and then we can read phase margin PM from the graph, which is equal to 35.4 degree. And then second step, we need to find PM or phase margin from the damping ratio, and from the value of overshoot we can find the damping ratio equal to 0.4. And then when we substitute into the formula, we got 2 PM equal to 43.12 seconds. And then we need to find the decibel. From this one, we need to use this function, and I take a phi MC equal to 5 degree. And then when we multiply, substitute all the parameters in the equation, we got the alpha equal to 0.64. And then after we got alpha, we need to find the value of decibel, which is we substitute all the parameter, and we got decibel is 1.94 decibel. And then from the graph above, we use the value of decibel, and we got the omega maximum is 9.4 rajang per second. This is we use the estimate value from the graph that we have plot in the MATLAB code. And then step 5, we need to find the compositor break frequency, which is 1 over t and 1 over alpha t. And when we substitute the parameter, we got this function, this value and this value. And then we have to check whether the bandwidth of the closed loop of the steady state responder is correct with what they want or not. So and then after we got the value of frequency, we substitute them into the G-lead transfer function, and we got this one. And then we need to plot this function by using closed loop code in the MATLAB, and from the graph we can get omega bandwidth, which is at decibel equal to -3, is 4.83 rajang per second. And after that, we need to find the GS according to this formula, and we substitute all the bandwidth and damping ratio. We got GS equal to 28.2 GS equal to 8.2 seconds. And as we know that we need the settling time is less than 5 seconds, so yes, this is okay for our design. But if we look at the overshoot, we will get overshoot is 33.6, which is greater than 25 seconds. So it's not good. Maybe we need to change another method to redesign the controller. We may change it to the length capacitor to match our design, which is OS equal to 25%. We may use lead capacitor design to match between TS and overshoot with value what we want. So that's all for my presentation. Thank you so much.